Alright, so I wanted to show you how to use Vpython just to model the motion of your fan cart that's moving with a constant acceleration. I use this video here as my example. There's the car that slows down and then it speeds up while moving to the left. So that's the motion we wish to model. I already showed you how to use Tracker and Logger Pro to get graphs like this right here. And I'm modeling the first part of the motion, this part here, that's a nice, clean, constant acceleration. I'd say the second half of the motion is probably a different acceleration, so I'm not going to worry about that right now. I'm just going to model this acceleration right here. This is a velocity graph, and I had an acceleration of about -7 centimeters per second. I had an initial velocity here of about 15 centimeters per second. My initial position was 0 meters. And I'm going to use some of that information with Vpython. Okay? In addition to that, I'm going to use our basic equations. X equals final position is initial position plus initial velocity times time plus 1/2 acceleration times time squared. And the other fundamental kinematics equation is V final velocity equals initial velocity plus acceleration times time. Okay? And I'm just going to start with David's program that he wrote. It's in the 6th tutorial, the 6th part. And here's the code that's already up for you. And if I run it, if I just press F5 and run it, let's see what his looks like. See, there's his car, and it slows down. Oh wait, no, looks like it sped up. So his car speeds up while moving in the positive direction, moving to the right. I'll close his down now. And what I did is I immediately changed this part and changed it to Mr. Day's slowing down and speeding up fan cart. And then I did file save as, and always put a .py at the end. That tells Python. That tells Python and tells your computer that it's a Python file. And then, so always put that extension at the end. If you don't, all your text will be the same color, and you'll miss some of the nice features of Vpython, like everything after the number sign is just a comment. So this part over to the right, that's all in red, and this part up here, these are just notes for me to understand the code, because I'm not like a super good coder. But it's nice to also look at, okay, this is loading the visual toolbox. So this code here, it looks like it loads the visual toolbox. And this is just it looks like it's tilting the camera for more of a bird's eye view. And I didn't change any of that. That was nice code, so I just left it alone. And this expands the window to fill the screen. I didn't mess with any of that. The only thing I started changing is where he has ball, I decided to change everything to car. And I have no problem with my car being a box. And I wanted my car to start basically at the position his object started. So I left this is the initial position of my car. And that was fine with me. I didn't change the color or anything. I didn't change the ground. But again, I changed everything in his code that says ball, I changed that to car. And then his car, you'll know, his ball, his object, has no initial velocity in the code, but I just changed initial velocity to 10, as you can see right there. So his object didn't have any initial velocity. I made my car with an initial velocity moving to the right, which is positive. His object had an acceleration to the right because it sped up. And what I did is I gave my car an initial velocity to the right, but I had its acceleration to the left in the negative direction. So this made it so that my car slowed down while moving to the right, and then later it sped up. And I didn't quite have, he had 16 seconds. I had to extend time a little bit to get my car to behave the way I wanted it to. This equation here, I didn't change at all. I just changed the name to car. And I had to be very careful to change everything. If there's one thing I forgot, it wouldn't work. So I had to change everything that said ball to car. And then I did change his equation for position. I made my equation so that it matched one of our fundamental kinematics equations. Basically, this equation is position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. And the dt you see is basically defined right here as 1,000th of a second. See right here, we set the time increment to 0.001 seconds. So I'm telling the computer to do its calculations every 1,000th of a second in the video. And well, it's not, there's no video, it's just I'm telling it to do that many calculations, 1,000 calculations in a second, which is super easy for a computer. And I'm telling it to do this for 28 seconds, so what's that, like 28,000 calculations that it's going to do. And basically this equation here sets the car's position, calculates the car's position again and again and again, you know, that 28,000 times. And this code here, I had to remember to change this part. He had it as ball.position, and I had to change that for my car. And what this does is the computer goes in this loop and goes through these calculations until it gets to 28 seconds and then it stops. So that's basically it. I'm going to put this file in the FanCart project section of your website so you can play around with it. You'll definitely want to change the initial position, initial velocity, the acceleration. You want to change, this value here is part of the physics. This part here, so those two, this line and this line you'll want to change. Possibly this line for the initial position, and then this is the initial velocity. The reason there's 3 numbers is we have an x, a y, and a z direction using Vpython. You'll only be using the x direction right now. So you can change the initial position here. You can change the initial velocity here, the acceleration here. I don't think you'll want to change our general equations. You won't really want to mess with them. But you'll notice by changing the initial conditions, you'll be able to model whatever your car did. I hope that helps. And again, this file, if you scroll to the bottom of the web page in the FanCart project, right here, FanCart projects, if you just scroll down to the bottom, you'll see this file here. and that's what you can download and modify for your own purposes. Anyway, I hope that helps, and thanks for watching. All right, good luck.